In this video, I will walk through the configuration settings required for a connection to a Modbus controller using the TopServer Modbus TCP Ethernet driver. This driver implements both client and server capabilities in the same driver, allowing communication with both server devices such as PLCs, RTUs, or other control and field devices, and client devices or systems such as HMIs, SCADAs, DCS, or PLCs. Data acquisition is optimized based on upstream client demand, while data integrity is ensured using extensive error handling. The Modbus Ethernet driver also features direct integration with Modicon Concept and ProWorks programming packages, allowing users to directly import the tags from the PLC into TopServer. I will cover the channel and device setup, give a summary of the settings encountered, and when it is appropriate to change them from the default values. The first step in configuring a connection to our device is to create a channel. A channel represents a communication link from the PC running TopServer to the controller. In the case of the Modbus TCP Ethernet driver, the channel represents the socket connection over which Ethernet communications will occur to the Modbus device. As a general rule for most TopServer Ethernet drivers, the recommendation for the best performance is that each individual controller or device be configured on its own unique channel, allowing simultaneous communications with all devices configured, as opposed to round-robin polling of one device at a time when multiple devices are on the same channel. The Modbus TCP Ethernet driver supports up to 1024 channels, so unless you have more than 1024 controllers, it's unnecessary to have more than one device on a single channel in TopServer. You can confirm the supported channel and device count information for a driver by going to Help, Support Information, clicking the Versions button, and selecting your desired driver from the list. We can click to create a channel and select our desired driver. For this demo, we will choose Modbus TCP IP Ethernet. The channel name is user configurable. It will determine how the channel appears in the TopServer tree view and how clients will reference devices under this channel. For demo purposes, I will simply call my channel Modbus TCP. Next, we can choose whether or not this channel should be included in a virtual network, and if yes, which virtual network the channel should be assigned to. While the recommendation for best performance is for each channel to communicate with the devices in parallel, communication can be serialized in cases with physical network restrictions, such as Ethernet radios. The term virtual network describes a collection of channels and associated devices that use the same pipeline for communications. This allows devices from different channels to behave in a round-robin manner by limiting data transmissions to one channel at a time. Virtual networks can improve and control radio modem communications and determine the amount of bandwidth being used. The transactions per cycle specifies the number of single read or write operations that can occur on the channel. When a channel is given the opportunity to communicate, this number of transactions is attempted. Next, you can define a specific network adapter or network interface card on the TopServer computer. The standard option of default allows Windows to select the appropriate network adapter based on the IP address defined for the device. Click Next to review the write optimization settings for this channel. These determine the optimal method of writes based on the write queue and the priority of write operations to read operations. These will generally be left at default but can be altered as needed. Click Next to review how the driver will handle non-normalized floating point values. This can generally be left at default unless non-normalized values such as not a number or infinity are expected. Next, we can specify the socket sharing behavior for all devices under this Ethernet channel. One socket per channel maintains a single socket that will open and close repeatedly to connect to devices configured under this channel. This setting can be used in situations where it is undesirable for the driver to maintain a connection to the device. For instance, if the device has a limited number of connections available and the TopServer is using a port, no other system may access the device. One or more sockets per device maintains one or more active socket connections for each device under the channel. Because the driver does not reestablish a connection each time it reads or writes data to a given device, connection overhead is reduced. When using one or more sockets per device, you have the ability to specify the maximum sockets available for each device on the channel. Devices typically limit the number of simultaneous connections to protect against communications conflicts. Make sure to confirm the number of supported concurrent socket connections for each device on a channel prior to using this setting and specifying a number of sockets greater than 1. The unsolicited port number will specify which port top server will accept incoming unsolicited requests on if the device is configured to send unsolicited TCP or UDP messages. Click Next to review a summary of the selected channel settings and change any if needed. You'll notice the name is in bold. This indicates a change from the default values. All of our settings are correct, so I'll click Finish to finalize the configuration and create the channel. Now we can add a new device to the channel. Select Click to add a device under the newly configured channel. The device name is user configurable. It will determine how the device appears in the top server tree view and how clients will reference devices under this channel. For this demo, I will call my device Modbus PLC. Next, we specify the device model for our Modbus controller. Since we're configuring a connection to a generic Modbus device, that's what we need to select from the drop-down. Next, we specify the device ID of the Modbus controller itself. This will be the IP address of the device on the network, followed by the Modbus bridge index. The Modbus TCP protocol specification defines the bridge index or node ID for a device as 0. I will specify a device ID of 192.168.111.121 with a bridge index of 0 for our controller. While a non-zero bridge index should technically only be used for devices connecting to a Modbus TCP to serial bridge, it is not uncommon for device manufacturers to still use a non-zero device or node ID. In that case, you would need to make sure and specify this as the bridge index in addition to the IP address. It is possible to configure the top server to act as a Modbus server or unsolicited device. In this case, the device ID would either be the loopback address 127.0.0.1 or the local IP address. More information on configuring unsolicited mode can be found in the driver help file under Overview Supported Device Models, which is beyond the scope of this tutorial. Now we need to specify the device's scan mode settings for subscription-based clients. Respect Client Specified Scan Rate simply respects the requested scan rate from client applications to determine how often to scan the device. Request Data No Faster Than sets a ceiling. Data will be requested no faster than the specified time frequency. Request All Data At means all data will be requested at the specified timing frequency. Do Not Scan Demand Pull Only means there will be no automatic scanning done of the device unless a plugin or client application manually triggers the pull via the demand pull system tag. Respect Tag Specified Scan Rate respects the scan rate specified at the tag level when you define static tags in the top server configuration. In systems where bandwidth utilization is not a concern, this setting should be left at default. Next, the timing settings should be set appropriately based on the level of network congestion. These can generally be left at the default and increased or decreased as needed. For instance, if you're seeing a lot of connection timeouts to the device, you may want to increase the connect timeout to give the device more time to accept the socket connection. If you're connected but seeing a lot of timeouts waiting for a response to your requests, you may need to increase the request timeout to give the device more time to respond. The goal is to have the timing settings as low as possible while still maintaining successful communications. This allows the driver to detect actual communications issues more quickly. Next, we can define the auto demotion settings to determine whether unresponsive devices will be taken out of the polling cycle for a specified period of time. In situations where multiple devices are configured under a single channel, which is normally not the case with most Ethernet drivers like this, we recommend enabling auto demotion and discarding write requests on devices that are written to frequently. Otherwise, write request will override the auto demotion period and attempt a connection immediately. Since devices under a channel are treated sequentially, this will prevent a down device from repeatedly slowing down communications for other devices on the channel. Since this is an Ethernet driver and there is only the one device on the channel, we will leave auto demotion at the default state of disabled. Click Next to specify the database creation settings. The driver can automatically generate a tag database from a CSV file, concept, or ProWorks. Here you can specify if and when the tag database will be created, how previously generated tags will be handled, and if you would like the tags to be included in a specified tag group. We will revisit this feature after the device has been created. Click Next to specify the port number for the device, as well as the transport protocol, TCP or UDP, that will be used for communications. Port 502 is the default port for Modbus TCP IP communication. Close socket on timeout specifies whether the driver should close a TCP socket connection if the device does not respond within the specified timeout. This setting is enabled by default. Next, we can specify the data access settings as they are appropriate for the Modbus device. These may need to be changed based on the protocol implementation for the specific controller. Zero-based addressing specifies whether the device address space is zero-based or one-based, meaning is the first address in the memory map 0 or 1. When enabled, this setting will reference the address with an offset of 1, whereas one-based addressing will reference the first register with an offset of 0. The default setting of enabled follows the convention of Modicon PLCs. Zero-based bit addressing specifies whether bits within registers should be addressed 0 to 15 when enabled or 1 to 16 when disabled. This setting will not affect what is sent to the device, only which bit the top server will reference for the specified register. Holding register bit rights will use function code 22 to change a single bit inside a holding register when enabled. If the device does not support this feature, this setting should be disabled and the driver must perform a read modify write operation to ensure that only the single bit is changed. Enabling Modbus function 6 allows the driver to switch between functions 6 and 16 based on the number of registers being written. For the standard Modicon PLC, the use of either of these functions is generally acceptable. If your Modbus device only supports function 16 to write to holding registers, this setting should be disabled. Enabling Modbus function 5 allows the driver to switch between functions 5 and 15 based on the number of coils being written. Again, for the standard Modicon PLC, the use of either of these functions is generally acceptable, but if your Modbus device only supports function 15 to write to output coils, this setting should be disabled. Next, we can specify the data encoding settings as appropriate for the device. Enabling Modbus byte order tells the top server to expect data sent using the default Modbus byte order of high order byte last. When disabled, the top server driver will expect data to be sent using the Intel byte order of low order byte last. First word low specifies whether the device will send the low order word first or second when dealing with 32-bit data types, as these will be stored in two Modbus registers. The default setting of enabled follows the convention of the Modicon ModSoft programming software. First D-word low specifies whether the device will send the low-order D-word first or second when dealing with 64-bit data types. The word order within each D-word is determined based on the previous setting for 32-bit data types. When Modicon bit order is enabled, the driver reverses the bit order on reads and writes to registers to follow the convention of the Modicon ModSoft programming software. This means writing to bit 0 in the top server will alter bit 15 in the device. This setting is disabled by default. When treat longs as decimals is enabled, the driver will encode and decode longs and D-word data types as double precision 64-bit unsigned decimal values. Values read above the specified range are not clamped, but the behavior is undefined. Next, we can specify the block sizes that should be used to read contiguous registers from the device. These indicate the maximum offsets for reading a range of addresses in a single request, rather than multiple smaller ones. Coils are limited from 8 to 2000 and registers are limited from 1 to 120. We recommend increasing the block size in telemetry situations to reduce the number of requests. However, block sizing may need to be decreased if your device contains non-contiguous addresses or does not support block read operations at the default size. Enabling block read strings allows group reads of string tags, which are normally read individually. String tags are grouped together depending on the selected block size. This setting is disabled by default. Next, we can specify the import file to be used if automatically generating the tag database. Although it is sometimes possible to query a device for the information needed to build a tag database, this driver must use a variable import file instead. Variable import files can be generated using device programming applications such as Concept and ProWorks. Next, we can specify how top server should handle situations where the device indicates we are referencing an illegal address. When this setting is enabled, top server will deactivate the erroneous tags and not waste time trying to pull them. Next, we can review the device settings in the summary and make any necessary changes. Again, you'll notice some settings in bold, which are the only ones we changed from defaults or entered for blank fields, which is only our device name and device ID. Click Finish to create the device. Now I can choose to define static tags manually in the server or dynamically in the client application. If you specified an import file to use for automatic tag generation, you can auto-generate the tags by right-clicking on the device, going to Properties, navigating to the Tag Generation tab, and using the Create Tags button. For this demo, I will create a sample tag in the server configuration. I will call my item text tag and give it an address of 4001. For more information on address formatting, you can view address hints by clicking the ellipsis button or going to the address description section in the driver help file. You'll notice an extra 0 was incorporated into the address, making it 40,001. While the top server Modbus driver supports address offset ranges of 1 to 65,536, your device may only support a smaller range. To avoid confusion when entering an address for such a device, this driver pads the address according to what was entered. What matters is the first digit in the address, which indicates the type of memory location, and the offset value. The addresses 4001 and 40,001 both access a holding register with an offset of 1. I can test the connection to my device by launching the Quick Client application here. Once the tags exist in Top Server, you have the ability to export the tag list as a CSV file by right-clicking on the device and choosing Export CSV. This feature can be especially helpful if you are able to import tags into your client application. You can always go back and delete any tags you do not need in the top server configuration, or you can get rid of all static tags if you are dynamically addressing from your client application. This video has shown the general steps required for quickly configuring a Modbus TCP Ethernet device in Top Server version 6 for process data collection. It is not intended to be a comprehensive how-to regarding the Modbus TCP Ethernet driver, and the Top Server Modbus TCP Ethernet driver help file should be referenced for further information.